Hi friends, today we are going to deal with purine nucleotide degradation. Basically, we know what is a nucleotide, right? It's a sugar plus a nitrogen base and a phosphate. When the nitrogen base is a purine, it's known as purine nucleotide. These are the basic things we know. Now we can go on to the pathway. So first we have to mention few things. That's the final product. Other name for this pathway, it's actually the final product that we are getting is the uric acid. So this is otherwise called uric acid synthesis pathway. And where this takes place? It takes place in the liver. And the major steps taking place are deamination, removal of ribose 1 phosphate immediately followed by 2 successive oxidation. So these are the major steps, and after all this we will get our uric acid ready. So we know the major purines, that is guanine and adenine, the most familiar purines. There are some minor purines also like hypoxanthine and xanthine. So when the adenine is a nitrogen base, the nucleotide is adenine monophosphate. Similarly, we have the guanine monophosphate, adenosine monophosphate. Okay, for those who are not much familiar with adenosine monophosphate, now I just mentioned about hypoxanthine. Now, this hypoxanthine combines with sugar, we will get inosine, and this is our nucleoside. Okay, this combines with the phosphate to give inosine monophosphate. So this is the nucleotide. Ready. First, let us deal with inosine monophosphate. This inosine monophosphate has actually two fields. It can be converted first to inosine monophosphate. It's not clear right now. So it can be converted to inosine monophosphate and then to inosine. Okay, then to inosine. Or else we can remove this phosphate group so that it can be converted into nucleoside, that is the adenosine, and then it can be converted to inosine. Now the enzymes, which are the enzymes? Adenosine monophosphate is converted into inosine monophosphate by deamination. So the enzyme is adenosine monophosphate deaminase, and we will get ammonium ion, NH4 plus. Okay, now the inosine monophosphate converted into inosine by removing this phosphate. So the enzyme is phosphomonoesterase, so that we will remove one inorganic phosphate. Okay, now the adenosine can be converted to inosine by deamination. So the enzyme is adenosine deaminase. We will get ammonia. Clear? So directly we can get this inosine from IMP, right? Inosine monophosphate. Just removing this phosphate, we will get inosine. Okay, now the inosine can be converted into hypoxanthine, that is by removing the sugar. We just said no, the hypoxanthine combines with sugar to form the inosine. So by removing the sugar, we will get the hypoxanthine. That's it. So inosine can be converted into hypoxanthine by removing the sugar, and the enzyme is PNP, that is purine nucleoside. Inosine is a nucleoside, so purine nucleoside phosphorylase. So in this step we are removing this ribose 1-phosphate. This ribose 1-phosphate has to be removed. No, the step we are removing this ribose 1-phosphate. Ribose 1-phosphate is removed. Clear? And again followed by two successive oxidation steps. So the hypoxanthine is converted into xanthine by the enzyme. This enzyme is a bit important enzyme, that is the xanthine oxidase. Why this is important? Because the xanthine oxidase enzyme is a metalloflavoprotein. So we will be having FAD, molybdenum and iron. Okay, so the electron will be first transferred into molybdenum actually. First transferred into molybdenum, then to FAD, and then to oxygen, from where we will be getting highly reactive species, that is the hydrogen peroxide. So in the step we will getting H2O plus O2, we will be getting hydrogen peroxide. Okay, we didn't mention about the guanosine monophosphate. No, so the guanosine monophosphate, again by removing this phosphate group, it can be converted into its corresponding nucleoside, that is the guanosine. So here we have to remember two enzymes. One is the guanase enzyme. I'll write it here, guanase enzyme, and the other one is our PNP, that is purine nucleoside phosphorylase. So if the enzyme first acting on the guanosine is guanase. Okay, suppose the enzyme is guanase, we will be getting xanthosine. Okay, and we will be removing one ammonium ion. If the enzyme acting is PNP, that is what we are using for removing our sugar group. So here also we will remove our sugar, that is ribose 1-phosphate. So the corresponding nitrogen base, that is the guanine, we will get the guanine. Okay, now this xanthosine can be converted into xanthine by removing the sugar. So the enzyme is again PNP, purine nucleoside phosphorylase. We will be removing ribose 1-phosphate and it is converted to xanthine. Similarly, the guanine can be converted to xanthine by guanase. Okay, this guanase will convert it into xanthine. Ammonia will be removed. Okay, the final step, the final oxidation, xanthine is converted into uric acid. The enzyme is saying xanthine oxidase. Again we will get H2O plus O2, H2O2. So the pathway is very simple. Now just mention this normal level of uric acid. In different male and female. In female it is 2 to 5 milligram per deciliter. In male it is 3 to 7 milligram per deciliter. That's in the blood. Okay. In the normal level excreted, it varies. It's a range between 500 to 700 milligram. It's easy to remember because 5, 7. So that 500 to 700 milligram. That's about the purine nucleotide degradation pathway. Hope all you understood. Thank you.